today we will start with the hydrocarbons. Okay, so this is the notes which I have prepared for you to remember. So what is actually hydrocarbon? Hydrocarbon is basically consist of two things. First, your hydro means your hydrogen. Second is your carbon. So can you give me an example of hydrocarbon? Hydrogen is also there, and when your carbon is also there. Any simple example? Rudra, any example? I can write CH4. I can write, no? CH4 is here. Your C2H6 is here. It means consist of your two things. Your carbon, your hydrogen, your carbon and your hydrogen. So, hello, Safia. So, Safia, we have started this new topic, hydrocarbon. Hydrocarbon basically consists of two things. First, your hydrogen, then your carbon. Example, you can write CH4, C2H6, any example which consists of your carbon and hydrogen. So that is basically your hydrocarbon. Now, if we will look a definition, the organic compound containing only the carbon and the hydrogen is known as the hydrocarbon. Example CH4, C2H6, C2H4, C2H2 means these all containing two things. First is your carbon, and the second one is your hydrogen. Okay, these two. So now hydrocarbon is classified into two types. First is your saturated and your unsaturated. Now, what is saturated hydrocarbons? So, carbon linked with a single covalent bond is known as saturated. Saturated means if like your carbon is linked with like this. Okay, but here is your single bond. So, this is what? This is a saturated hydrocarbon means between the carbon there is a single bond that is known as saturated. Example, alkane. And alkane formula is CnH2n plus 2. Now if let me put n is equal to 1, so it will be C1H2 plus 2, it will be 4. So see C and 4. Okay, and if I am putting n is equal to 2, then it will be C2H2 2 plus 2 means 8. So here it will be C 1 2 3 1 2 3. Okay, wait. Sorry, it will be 6 over here. That's why I'm taking 6. So it will be 1 2 3 4 5 and 6. So here how many carbon atom is like forming in a single bond? This is a single bond. So this is a saturated hydrocarbon which consists of a single bond. Now what is unsaturated? Unsaturated means at least one double bond or triple bond like this, or you can say like this. This is your unsaturated. So here how many carbon? 1 2 3 4 1 2 3 4 H H H H. So it will be C2H4, and here also 4 4 1 1. So it will be C2H2. Okay. So this is what this consists of your double or triple bond, and saturated consists of only single bond. And we can also say saturated example is alkanes. Why? Because alkanes always consist of a single bond, and this is the formula of your alkane. So this part is clear, what is saturated and unsaturated hydrocarbons. Any doubt, Rudra and Safia? Okay, now next, alkane we already discussed that it consists of a single bond, है ना? So now we will discuss alkene and alkyne. Now what is alkene? Alkene means at least one double bond. It should be at least one double bond should be there, like this, or only one double bond should be there. Okay, so that is your alkene, and formula of alkene is CnH2n. So let's say if I'm writing CS2, so it will be 2 and 4. So here your formula will become as C2H4. Okay, here will be H H H H. Or if I'm writing n is equal to 3, it will be C3H6. So C3H 1 2 3 4 5 and 6. The thing is we have to put carbon carbon in a double bond only in one. Like here we can't put double double bond, only in the series of, like, let's say there's lots of series. Okay, so here we can put double bond. This is what your alkene. Okay, it's not like we have to put double bond in all the carbon carbon bonds. No, we have to put the double bond in only one of the carbon carbon thing. So just a minute. Okay, sorry. Here also H and here also H. That then only it becomes H6, 1, 2, 3, 4, 5, and 6. This carbon is having four bonds, 1, 2, 3, 4. This is having four, 1, 2, 3, and 4, and this is also having four. Now this is your C3H6. Now next is your alkynes. What is alkynes? Alkynes having more than one triple bonds like this. So alkyne, first of all, your alkane formula was CnH2n plus 2. Your alkene was CnH2n and your alkyne is CnH2n minus 2. So if I am writing, if I'm taking n is equal to 1, then it will be C1H. No, wait, let me take n is equal to, yeah. Why? Because why I'm not taking n is equal to 1? Because n is equal to 1 in both the alkenes and alkynes is not possible. That's why we have to take n is equal to 2. But n is equal to 1 is possible in your alkane, but in alkene and alkynes, your n is equal to 1 is not possible. So here I am writing 2H4 minus 2, which is equals to your 2. Okay, so it will be C2H2. This is your formula. This is your formula. It will contain C triple bond. So this you got alkane. The formula is CnH2n plus 2. Here we can take n is equals to 1, but in alkane we can take n is equals to 1, but in alkene and alkyne we can't take n is equals to 1. We have to start with n is equals to 2. So here the formula is CnH2n plus 2. It consists of a single bond. Okay. In alkene, your formula is CnH2n. It consists of a double bond. And alkyne, this formula is CnH2n minus 2, which consists of a triple bond. Understood? Any doubt? And what is saturated? Saturated means which consists of a single bond. We can say alkanes. Alkanes, we can give it example over here. Why? Because alkane is having a single bond. And what about unsaturated? Unsaturated means at least one double or triple bonds. So unsaturated is these two. Your alkanes and alkynes are unsaturated, but your alkanes comes under saturated point. Okay? Alkenes and alkynes are unsaturated and alkanes is saturated. Next, and what is hydrocarbon? Hydrocarbon means which consists of hydrogen as well as your carbon. Example is this, or we can take any example, but it should contain both the carbon and the hydrogen. Now, next, here. So, let's go with the definition. Saturated hydrocarbon, the hydrocarbon in which all the carbon atoms are linked by only one single bond. Hello, Roshni, you are late. Okay, so Roshni, we started with this topic, hydrocarbons. Okay, so do you know what is hydrocarbon? What is saturated and unsaturated hydrocarbons? Any idea? Hmm? Roshni, any idea? So what is hydrocarbons? What is hydrocarbons? Okay, so let me tell you very quickly because we have already discussed all these. Okay, so what is hydrocarbon? Hydrocarbon consists of two things. First, your hydrogen and your carbon. For example, CH4, C2H6. But the main thing is it should contain these two hydrogen as well as your carbon. This is the basic thing of your hydrocarbon definition is the organic compounds containing the carbon, carbon and hydrogen is known as the hydrocarbon. Your example CH4, C2H6, C2H4, and C2H2. Okay, so hydrocarbon means carbon and hydrogen. Next, hydrocarbon is classified into two types. First is your saturated hydrocarbons, and then your unsaturated hydrocarbon. Now, what is a saturated hydrocarbons, Roshni? Any idea about saturated hydrocarbons? Come on, tell
They're like
me.
the hydrocarbons
Hmm.
having like single covalent bonds between the carbon
Yeah,
atoms.
between the carbon. Yeah. So carbon atom, they'll have a single covalent bond. So the example we can call it as like alkane. Why? Because alkane is having a single bond between a carbon, and the formula of alkane is CnH2n plus 2. So if I'm taking, let's say n is equal to 1, it will be like this. If I'm taking n is equal to 2, it will be C2 and there will be H8. So there's a only one bond between the carbon atom. So your saturated is the carbon which is having a single bond between the carbon. So that's alkane. Next is your unsaturated. Unsaturated means at least it should have double or triple bond. So example, first of all we will look this alkane. Next we will discuss here alkenes and alkynes. So alkenes and alkynes are basically your unsaturated hydrocarbons, and your alkanes are saturated hydrocarbons. So what about alkenes? Alkenes means it's having one double bond. Like here, if I'm taking n is equal to 2, it will be C2H4. So here it's your double bond. If I'm taking n is equal to 3, so it will be C3H8. So here is your double bond, and this is the structure of your C3H8. So it means it's not like in all the series we have to put double bonds. No, only in the one place we can put a double bond, so that will consider as your alkenes. Now what about alkynes? Alkynes means they will have a triple bond. And the formula of alkene is CnH2n. What was the formula of alkane, Roshni? What was the formula of alkane? Safia, what was
Ma-
the yeah, go
Ma'am,
ahead.
CnH2n plus 2.
Yeah, CnH2n plus 2. And alkene is CnH2n. What about alkyne? Alkyne is CnH2n minus 2. And they will have triple bonds between the carbon atom. So like if I'm taking n is equals to 2, so it will be triple triple and then 1 hydrogen. And here why I'm not taking n is equal to 1 in both of these alkenes and alkynes, because n is equal to 1 is not possible in alkene and alkyne. Only n is equal to 1 is possible. See, n is equal to 1 is only possible in your alkane. In alkene and alkyne, your n is equal to 1 is not possible. So your unsaturated is basically these two, alkenes and alkynes, and your saturated is alkane. Why? Because single bond, and unsaturated is having a double or triple bond. So alkene is double and alkyne is triple, and these are the formulas. Now we will go with the definition. First is your saturated. Saturated means your single bond. Saturated means your single bond. And what about your unsaturated? Unsaturated means your double, or we can say triple bond, which is your alkene and alkyne. And here your alkane. Okay, now so the single covalent bond, which is known as the saturated. Example of alkane is this CnH2n plus 2. And what is N? N is the number of carbon atom, or we can say a positive integer. Your n is also, we can say, a positive integer. So we can take a value of n 1, 2, 3, 4, 5, anything. Next example, if there is only one carbon atom, then it's CH4 methane. If there is two, then it will be C2H6, which is ethane. And what about unsaturated? Unsaturated means at least one double and triple bonding along with a single bond is known as unsaturated. Means it will be like this: double along with a single, or it will be triple along with some single bond. So and in unsaturated, you will have these two, alkenes and alkynes. First of all, we'll look alkene. Alkene is having double bond, and also single bond will also present, that is your alkene. So if we'll take example of n is equal to 2, it will be ethene. What about alkyne? Alkyne is having more triple bonds with a single bond, which is alkyne. So alkyne is over here with a, where is it? Yeah, with a triple bond, and alkene is with a double bond even with your single bond. This is your single bond and this is your double bond. Okay. So next, this you got alkyne have a two carbon. So this is your ethyne and this is your propyne. So we will discuss the IUPAC name, the nomenclature also. But first of all, you should know what is alkane, what is the formula of alkane, alkene, and alkynes. Next is your structure of saturated and unsaturated. So first of all, if we will look about C2H6, these all are your saturated. Okay. Just a second. Sorry. So here, first what we have to do, first connect all carbon atoms together within a single bond. Okay, first we have to connect what? All the carbon atoms within a single bond. After that, use the hydrogen atom. And if the available H plus is less, then what we need to do? We need to satisfy the remaining valency by using a double or triple bond. So first of all, your rule is that we have to start with a double bond. Then we have to put a hydrogen over here, over here, over here, over here. And the third rule is that if your hydrogen is more, then what we have to do? We have to make double, or we have to make a triple bond. But the first rule is we have to make a single bond of the carbon-carbon atom. So first we will see this example, C2H6. C2H6 is very simple. What we have to do? We should take 2C2 and 1, 2, 3, 4, 5, 6, 6H. So this is done. Your C2H6. Okay. So C2H6, the tetravalency of carbon in ethane is satisfied. So electron dot structure will be like this. You already know how to make electron dot structure. We have already discussed. What about propane? Means we have to make C3H8. If we will make C3H8, it will be like C3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, simple. First rule was that we have to make first carbon-carbon single bond atoms. Second is your C2H, C2H4. Now what we have to do? C2. Uh-oh. So here what we need to do is, here we can make two carbons and two hydrogen like this. Like this. Yeah, like this we can make. Okay? The carbon bond, two bonds, and this. And this is what? Your alkane or alkyne. Two is over here. So it will be alkene. Two bond means alkene. So if let's say, let me make a like this. So it will be 1, 2, 3, and 4. So no, it's not the way to make na. Yes. So it's not the way to make. Why? Because if I'm writing H 4H, so the carbon will have four, no? In the last outermost shell, the carbon will have the four electrons. So here one and one atom, sorry, one atom of hydrogen is not present. So this structure is wrong. Now what we have to make? We have to make like this. Why? Because carbon should also get the four bonds with the hydrogen, and here also carbon should get the four, and the hydrogen should get only one. This is your one. Here its hydrogen part is satisfying, but your carbon part is not satisfying. Carbon is getting only three bonds of hydrogen. One is not here. That's why this whole structure is wrong. Next, ethene. Got it? Now you got it now, that why we are making a double bond, why we are using double bond instead of a single bond. Safia, Rudra, Roshni. Now you got it. Why me if we are using double and triple bonds? At least reply. Okay, nobody. So the third one is your second is C2H2. So if I have to make this C2H2, then you tell me what I have to use. I have to use double bond, triple bond, single bond. Which bond? Roshni. C2H2, which bond we will use? Alkane, alkene, or alkyne? Single, double, or triple? Safia, at least you tell. Tell me. Alkene. Wait, what? Let me see. Alkenes double bond. Okay, let me make alkenes double bond. So here it will be like this. Alkene means like this, and your H2. No, this is wrong. We have to make alkyne. Why? Because see, if I'm writing, oh, wait, if I'm writing HH over here, then your only H2 is here. So your H2 part is getting one atom, one bonding from the carbon, but carbon is not getting four, no. This and this part is not over here. So how can I make alkene? I have to make alkyne. Why? Because if I will use triple bond and one hydrogen, then this is also satisfying and this part is also satisfying. Carbon is getting four, and uh-oh, pencil got discharged. Just a second. Hmm. So your here your carbon is also getting four and hydrogen is also getting one. But here, if I'm making alkene double bonds, then here only hydrogen is satisfying. Now carbon is not satisfying because carbon is getting only three bonds. Safia, you got it?
Yes, ma'am.
So why you got confused? Okay. Now, so this is also you're satisfying. So C2H2 means triple bond. Your C2H4 means your double bond. Next, and you can also check with the formula. The alkane formula was CnH2n, right? And alkyne was your CnH2n minus 2. So here how many carbons? Two carbon. So if I am writing n is equal to 2, then it will be at 4. It means this formula is satisfying your alkene wala group. And here your Hn is 2. So if I'm writing C2 and H2 is there? Yeah. C2 and H2. So this is satisfying your alkyne wala group. So we can also see with the formula, but the thing is we have to be logical that why carbon can make that how the carbon will make a triple bond or a double bond, and which alkene or alkyne will apply. So this part is also clear. C2H2. Next, see here also it's like this. Same we did here. Yes. Next is your structure of cyclic compound. Okay. So C6H12, now you tell me, C6H12, which formula, which property, alkane, alkene, or alkyne will apply? Okay, let me check your message. Alkene. Okay, alkene. But first, let me try with alkane. So if I'm trying with alkane, it's 6, 1, 2, 3, 4, 5, and 6, and 12 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, your this is wrong. Means it should be H14, no? So here, if we will try with alkene, then it will be C. Somewhere it will be double bond. So 1, 2, 3, 4, 5, and 6, and your 12 hydrogen. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Let me write first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 hydrogen. So here, yes, this is correct now. This is having 4. This is also having 2, 3, 4. All 4, 4, 4, 4. So alkane, very good, Sophia. Alkene we will apply. So this is what? This is your ring structure. This is like a ring structure that what we have to do first we have to make the 6C 1, 2, 3, 4, 5, and 6, and then we have to add all the hydrogen. So this is what? This is like your single bond. So here your alkene thing is not satisfying. This is the structure of actually your cyclic compound. No? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, 12 hydrogen will also satisfy. Then why not over here? 1, 2, 3, 4, 5, 6. Okay, yes. This is the cyclic one. So if it will say a cyclic, then what you have to do first you have to go with the alkane. Okay, okay, see, just like H6, C6 and H6. Then what we have to do first we have to make this yes, 1, 2, 3, 4, 5, 6, and then what we have to do? 1, 2, 3, 4, 5, 6. Sorry, one bond now. 1, 2, 3, 4, 5, and 6. So 6H will be there. So this part is wrong. Why? Because we have to make a cyclic compound. Okay, so cyclic compound will be. It's not like it's wrong. It's correct. But if it's asking that you have to make like a cyclic compound, then you have to make like this. Okay, 6, and then you have to make 2 to each hydrogen in each carbon. Here also 2. So it's total 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Safia, you got it? Because this is the topic of your cyclic compounds. That's why. But that was also correct. But in the cyclic way, we have to make it like this. Got it? Next.
Yes, ma'am.
Next is this. This also we did. What about next? Next is your benzene. Now, if we have to make C6 and H6, then what we will do? C6 and H6 we have to make. Then first we have to make the C6 like this we have to make. And then what we have to do? We have to add 6 H6. If I'm adding 6 hydrogen over here, 1, 2, 3, 4, 5. Oh, I made it wrong. Just a second. This is so here what do benzene, no? So 1, I'm making like this, 2, 3, 4, and then 5. Yes, and then 6. Then what we have to do? We have to add 6 hydrogen. So if I'm adding 6, sorry, 1, 2, 3, 4, 5, 6, then it's wrong. Why? Because carbon is having how many bonds? 3 bonds. So what we have to make? We have to make carbon as a 4 bond. So what we have to do? We have to attach one bond. So let's say if I'm adding it, if I'm attaching over here, that will be 1, 2, 3, 4, and for this also it will be 1, 2, 3, 4. If I'm attaching over here, then it will be 1, 2, 3, 4. For this also it's 4. And here if I'm attaching, then it's also 4 for this and 4 for this. So it's like a your benzene. Benzene is like this, like here. No, not here. Here, here, and here. This is the structure of your benzene. Got it? Got it? Any doubt? So this was your actually benzene. Okay? Okay, now the cyclic one you got it now. That how we are making there was C6 and H6. So how to make this as a cyclic compound? You got it now? 1, 2, 3, 4, 5, 6. And 2, 2 hydrogen everywhere. Sorry, 1, 1 hydrogen here, here, here. It will be only 4. So what we will do? We will add one thing. So this satisfied. Here, this satisfied. Here, this satisfied. So this is the structure of your benzene. Okay, so this was your cyclic compound structure. Next, this is also done. Now this is the next topic, your isomerism. So what is isomerism? What is isomerism? See, this will have the same molecular formula but different chemical and physical properties. This is your structural isomers. Okay, so here if we will see, this is the basic, this is the definition of your isomerism, but let me give you guys example, then it will be easy for you. Let's say here, just look the example, no need to look all these. This example and this example. So the structure is different. Structure is different. A carbon bond is over here, here a carbon bond is over here. So the structure is different, but the molecular formula is C4H8 and here also C4H8. It means your molecular formula is same, but the structure is different, correct? So the molecular formula is same, but the structure is different, so this is basically known as your isomers. Got it? What is isomers? Means the same molecular formula but the different structures. Safia, got it? Now we will see some of the functional groups. What is functional group? See, for alcohol, what we are taking? OH. For chlorine, Cl, bromine, fluorine, and iodine, this. For ketone, we are using like this. This is your ketone. And for carboxylic acid, we will use this. So this is basically your functional group. So now tell me, now you tell me any idea about homologous series. What is homologous series? So let me, this is the table. Okay, this is the table that here I am writing all the number of carbon atoms. This is alkane, this is alkene, and this is alkyne. We all know formula CnH2n plus 2, CnH2n, and CnH2n minus 2. So if I'm writing CH4 and if I'm taking n is equals to 1, so it will be CH4 simple. And this is your saturated, but here n is equal to 1 and here also n is equal to 1 is not possible. Why? Because of n is equal to 1, and if we will take n is equal to 2, then it's possible. Now let me take n is equals to 2. So if I'm taking n is equals to 2, so it will be single bond in between the two carbon atom and 6. Here it will be H2, C2H4, so double bond. Here C2H2 means triple bond. Next, if I'm taking n is equals to 3, it will be C3H8, C3H6. See, in this is the series. This is what? This is your homologous series. So here, no need to write double bond over here also. No, we will not do like this. Only the thing we have to make in the homologous series, only in the one place we have to make it double, that's it. Only in the one place here we have to make it a triple bond. No need to make in all of the between carbon. Okay, so here this is your C3H4. So here see, I've made here carbon triple bonds, and this is the structure of C3H4. This is your n is equals to 4 if I'm taking, so it will be C4H10, C4H8, C4H6. N is equals to 5, C5H12, C5H10, and C5H8. So you have to make till N is equals to 10, okay, of all the alkanes, of all the alkynes and the alkenes. Okay, now you got it. What is homologous? And the main thing about homologous series is, see, the difference between these two, C2H4 and C3H8 is CH2. Okay, here also the difference between C2H2 and C3H4 is CH2. Here also the difference between C2H6 and C3H8 is CH2. This means that the molecular formula by a CH2 unit is known as the homologous series. So these are what? These are the members of the alkane family. Means it will be compulsory that it will, the difference between the two will be C2CH2. Here also you can see, if we will subtract this C5H10 minus C4H8, what we will get? We will get CH2. Here also, if we will see C5H8 minus C4H6, it will be CH2. Here also, if we will see, it's also your CH2. Means the difference is everywhere, the difference is CH2. So this is saying that a series of similarly constituted compounds in which the members present have same functional group, similar chemical properties, and any two successive members in the particular series, but the difference is with a CH2 unit. So that is known as your homologous series. And I've already showed what is the difference, means what is the meaning of H2 difference and all the in between the two carbon atom. Okay. Now what is next? Next is your nomenclature. Now see, if any diagram is given, let's say this diagram is given, and here it's iodine, your chlorine, and your bromine. Okay. So one needs to be made. So you have to name this thing as hydrogen. Why? Because carbon and hydrogen is like a brother. So without brother, the other brother is not going anywhere. So the carbon and it will combine with hydrogen. Here also carbon, hydrogen, hydrogen, everywhere hydrogen, hydrogen will combine. So see, if this is one bond, then it's ane, double, ene, triple, ine. If I'm writing like this, if I'm writing like this, then it will be ethane. Okay. And one more thing. See, your carbon one means meth. Carbon two means eth. Three prop, four but, five pent, six hex, seven hep, eight oct, nine non, 10 dec, 11 undec, but only till 10 is compulsory for you to remember. So here is only how many carbons? Two carbons. So for two carbons, what we have to write? We have to write it. So it will be and one bond. So it will be ane means ethane. Okay. Here how many carbons? One carbon, two carbon, and three carbon. So for three carbon, we have to write what? We have to write prop. And how many bonds? Only single bond. So it will be propane. Next is this. How many bonds? Sorry, how many carbon? Two carbon. For two, we write what? It, right? And how many bonds? Two bonds. So for two, we have to write ene. So it will be ethene. Okay. Here, how many carbon? Two carbon. It means it. And there's three bonding. So it will be ethyne. Next, if I'm taking this example. So here, how many? One carbon, two carbon, three, and four. So for four carbon, we have to write but and one and double bond is here. So what we will write? We will write butene. But what we have to do? We have to number this and we have to like numbering from which that double bond is closer. So here your double bond is closer. So we have to start numbering from this. So we can write but one in also or we can write butene also. But it's your choice. Either you write one in or butene. Now this. So we have to we have to start first numbering this. So if I'm numbering it this from here 1 2 3 and 4, so it will be what? It will be 2 but 2 and ene. 2, why? Because in 2 there's a double bond. So and but means your four carbons and ene means your double bond. So it will be but 2 ene. Okay, so this is the longest CC chain. We will study this later. CC chain, some uh, subsequents. So this you have to remember IUPAC name of all the carbons, if it's one, two, three, or anything. This is the prefix and suffix. We will learn it later. Okay. So understood today's lecture? Any doubt anywhere? Safia, Rudra, and Roshni. And you have to remember this also: functional group of alkane. Sorry, alcohol, aldehyde, ketone, and carboxylic acid. Okay. Thank you. Bye bye. Thank you.